So my name is Ryan Madsen. I actually had the pleasure of talking with a bunch of you guys 2 years ago about EOS SDK. This time, I'm not talking about any C++ APIs, though. We'll be going into CloudVision and what we're doing with telemetry and building off of what Ken just talked about. So I wanted to let me first start by describing why we jumped into the monitoring space. Why did we need to do something out there? There's a lot of great open series time series databases out there, Grafana, and a bunch of other tools. Why did we need to start providing a different monitoring platform? And the answer kind of came down to two reasons. First, there wasn't a great way to get state from boxes. Most people and most systems were entirely focused on screen scraping and polling data at regular intervals. And our largest customers came to us and said, this just isn't good enough. We're not going to be able to get all of the data that we need. If we want to have comprehensive knowledge about how our network is behaving, then we need to have full access into knowing what the switch was thinking about across all of its different protocols, all of its different interfaces and counters. We can't just rely on what's available over SNMP. And the second reason is these customers needed a real-time system to monitor their network. We've seen across different industries, if you lengthen the amount of the time during to iterate, then you're just not going to catch problems as quickly. If you make a configuration change and you don't see something show up in your monitoring platform right away, it's just going to sit there idle for weeks until an angry application developer comes at you and says, what's going wrong? Why is my application behaving slower? And you realize that the change multiple weeks ago is the root cause. So you really need to have something real time, not near real time, in order to understand what's going on in your network. And just to illustrate the problem with polling data. Now, the switch state, if you're going to start up two monitoring systems, you're going to have a system which polls your state and the system which streams your state. At the beginning, they both send out the same thing. The interface is operationally up in this case. Now, the polling system has to come back once a minute, once every 30 seconds, once a day, whatever you configure it to do, and keep asking, hey, is the interface up? And you'll see that state. Now, when a switch state changes, the polling system isn't going to notice it right away, whereas an event-driven system is going to get this notification and immediately push it off of the box. And similarly, when the interface goes back up, that state's going to be streamed out immediately. Now, if you're unlucky, and you're going to be unlucky a lot if your polling has long enough intervals, you're just going to miss this entirely. And then you're going to keep polling and keep polling. And so not only are you missing data, but you're wasting a lot of bandwidth. It's really inefficient for the switch, and it's inefficient for the controller, too.
I'm sorry, I have to jump in here. You don't poll just for interface state. You poll for the timestamp that says the interface change state, so that you capture the stuff that happened in between.
Sure.
Sorry, I couldn't resist.
No, yeah, that's right. So interfaces, I bring up interfaces as an easy example. But maybe the timestamp of every single IP route in your network, you don't have that notification of when exactly a route was learned, or MAC address, or when spanning tree decided to change a port to discarding. So what we have with EOS from day one was a state-driven system where everything is event-driven, not just interface operational states. And so this means when an agent learns about a new piece of state, maybe this green dot right here is a new route that our routing agent learned. It's going to push it through EOS to any agent that cares about it. Maybe it's a CLI, so when you type show IP route, you'll see the new route. Maybe it's a forwarding agent, so we can program that route into hardware. With the NetDB streaming, what Ken was talking about, we introduced a new agent which will just stream this update off the box. Now, this agent in itself doesn't really care about CloudVision. As Ken mentioned, a lot of our large customers are using this fire hose of data and ingesting it themselves to listen to everything that's happening on their network. But with this powerful agent, you get both real-time updates, and also you get all of this control plane state.
So this is really like a message queue.
Yeah.
It's just streaming off of multiple devices instead of the traditional system that you'd have. Okay.
Exactly, yeah. So, and I mean, most traditional systems, if you were trying to build a centralized controller, understand what was going on in your network, the CloudVision Telemetry application would have to go and say, hey, switch 1, what's going on? Hey, switch 2, what's going on?
Are you doing any local preprocessing before streaming the data?
The pre-processing we do is we turn it into a standardized format, so you can stream off in JSON or gRPC, and we timestamp it on the box. But there's no other pre-processing going on. As
Can
far
you
as
stream delta rather than you subscribe through XPath to particular value in the leaf, but what if I only want to get a delta between old value and new value rather than the value itself?
So, I mean, that's the great thing about state streaming is we're actually streaming only deltas.
Oh.
At startup, we'll stream the full routing table or MAC address table because you need to know the initial state of the world. But after that, we're never going to send spurious updates saying, hey, the MAC table's still the same. We'll only send an update when a new entry is learned or an entry expires. Now, once this update is in CloudVision Telemetry, we do two things with it. We first store it for all time. And so that way a user can come back and say, hey, what was my interface counters over the past 2 weeks? Or what did this protocol, what did BGP know about at this point in time? And the other thing we do is we said this real-time aspect of streaming data off this switch is really powerful. We don't want to terminate the feed there. So we put it into a Kafka, another pub subsystem, so this data can stream out to external clients. And these clients can have a single point, connect to a single API, and receive updates from all of their network. So this is great, but now we have just a bunch of raw state in our database, which isn't that useful for most people. Our large customers love it. They can go and mine it to their heart's content. But other customers who don't have as large engineering teams are going to have a lot harder time making sense of it. And so this is where the Turbines APIs comes in. And we are building out a large number of these turbines, and they do all sorts of things. They might do data normalization, so they take our internal data models and they turn it into something well-versioned. So even though we have a single EOS release that works across all of our switches, over time, these models are going to change inside the EOS release from 4.19 to 4.20. So data normalization means that external clients don't have to worry about what version of the operating system is running underneath the hood. Once you do that, you can start aggregating this data. You can start looking at smoothing out interface counters over a period of a day or a week, calculating standard deviations. And then you can start to do anomaly detection and say, hey, this counter is trending in a weird direction that it hasn't previously been in. Since you have all the switch state in a single place, you can do topology calculations and say, this switch is connected to that switch, and I know which interfaces they are connected to, so I can do validation about MTU, or you can start to do smarter events by knowing how all of your network is connected. And then you can start to do forecasting and look at, across my network, my host table and my other hardware resource utilization is growing at this amount. I'm going to need to expand my network in about 3 months' time. You can start to do those sorts of calculations. So all sorts of stuff that you can do. Now, yeah.
When you mention things like standard deviation, I've been looking at this more from the perspective of net management tools, but most of the net management tools that I'm aware of think of it as compared to just general traffic. And what I've been wondering, we hear a lot about machine intelligence, but what about just doing trending on, say, 15-minute buckets during the day and detecting standard deviations for that time slot rather than compared to the traffic that's been going on around the last 24 hours or whatever?
Yeah, there's all sorts of really interesting techniques to deal with streaming data and be able to process it. We definitely have been looking at LSTMs and all sorts of machine learning techniques, but as you mentioned, there's a lot of low-hanging fruit that can get you there. Simple threshold detection is often very powerful if you're not even monitoring something at all, and you can make it a little bit smarter by doing certain types of dynamic thresholding. So the state updates look kind of like they do for the rest of EOS. When an update comes into CloudVision, it'll then push it out to anybody who cares about this update. So this data normalization turbine will subscribe to a certain path, maybe the BGP peers. And when a BGP peer changes, it'll normalize that state, and then put it back into CloudVision Telemetry. So CloudVision Telemetry at this point doesn't care about switch state. It's just a key value store with some really nice historical data semantics. And so anybody can end up putting things in here. And you end up with a centralized store to subscribe to all of your network data. And then this update can, well, let me first say, everything in that blue box is bundled in CloudVision. So this is all included in the CloudVision product, which is an on-premise SIS deployment that people can install inside of their network. Now, the same APIs that we use internally are also available externally. And these APIs to CloudVision Telemetry is a gRPC API, as well as a JSON-based WebSocket API for notifications, or JSON REST API, if you want to just get a specific path. And so if you're subscribing to some data, you'll be able to specify a path. And then whenever that data changes, it'll be pushed to your application. So that's really what we've been building over the past 2 years for CloudVision Telemetry, a single place to be able to store all of your network data and then analyze it in order to produce useful results. And on top of that, then we could actually build a user interface to let people make use of that data. All right, let's jump into the demo then. And if luck is on my side.
Question.
Yeah.
So the word of the day is intent, right?
I intend to demo this to you. I mean, there's enough buzzwords going around, and I think there'll be another word coming out in a week, and we're focusing on building the best product we can here. So for the telemetry platform we're building on top of CloudVision, the goal is to let people confidently manage their network. Is that large enough for you all to see? And by confident, you don't want to inundate people with a ton of data, but at the same time, you want to let people drill down into the data that they care about. So I'm on the front screen, and there's a lot going on. But when you wake up in the morning on a Monday, you probably want to make sure that your network hasn't melted down. And that's where the events application comes in. So at the bottom of the screen, we have a timeline, and you can see how events have happened over time. You can see which interfaces have been seeing discards, which interfaces went from operational to not operational. And you can see a nice summary of what's happened, which devices are seeing the most events. Now, when you click on one of these events, what we'll try and do is we don't want to cause you more work. We don't want this to be the end of your experience with CloudVision, where you have to go and then log into the switch and say, OK, what actually happened? I mean, if this happened yesterday, you're going to have no clue what ended up happening. Here, we can see that the queue size exceeded some threshold. We have this feature in EOS called lands, which internally tracks the buffer utilization. And if that goes beyond a certain point, you might have congestion in your network. So if you look at this lands queue length, you can see there was a spike. Now I'm going to zoom in here. And you can see at about 12:48 and 12 seconds, and 0.041 milliseconds, or 0.041 seconds, the length of the queue started going from about 1,000 segments up to 3,000 segments. So this started at 4812, and it ended at 4812.5, so a half second later. And all of this data is streamed from the switches into the back end to the front end in real time. But you're not going to miss any of this data. It's all there for you. It's equally important to be able to be able to drill into things on demand, though. Maybe you just want to check out something in your network. Maybe you're trying to look at your routing table, or and there's not an event per se that you care about. This is where the devices page comes in. So here, you can click on a device, and it will show you all sorts of relevant information for that device. You can look at system information. You can see how CPU utilization has changed over time. And at the bottom, we have this great timeline. So you can increase this timeline and move it around. And you can see what's been going on. You can see that Bangkok has these small CPU spikes from time to time. And this is probably where you want to start to ask, what's actually causing these CPU spikes? Most systems, you just say, well, if it keeps happening, I'll start running top on it in real time and figure out what's going on. We actually store a ton of data underneath the hood, so we can actually look at the per process CPU utilization information and see which processes are using the most CPU and which processes are using the most memory. And you can see there's a couple long-running processes here at the bottom. Our forwarding agent's using about 20% CPU on average. SysDB is barely touching the CPU. Our NetDB streaming agent is using 5% of CPU. What these spikes are coming from is these CLIs, which get spun up at 1204, 1214, 1224. So there's clearly some scheduled job that's running a CLI and is causing these CPU spikes. But with a couple clicks, you're able to ascertain that as opposed to scratching your head and wondering what happened. And we try and bring this drill down knowledge across these pages. In hardware capacity, you're able to look at, OK, how much of my MAC table is being used, how much is my host table being used, and then beyond that, what's actually inside of my host table. Apparently, a bit of some v4 hosts, and then slightly more v6 hosts, 56 vhosts entry.
Coming back to that CPU thingy, what's the granularity of that graph?
That granularity, so when we're getting data from Linux, sometimes internally we're going to have to pull. And right now, the NetDB streaming agent goes and asks kernel proc, the proc file system, once every 10 seconds, I believe.
Okay.
So
a few seconds.
Yeah. And that's only because the kernel doesn't stream this stuff out.
Yeah, so and it's polling inside the device because kernel.
Yeah.
And then it's streaming toward CloudVision.
Exactly.
Okay.
Yeah.
Big picture question. It's capturing all this event data.
Mm-hmm.
If I want to, I can drill down on a particular device and poke around and look for stuff. If I have 1,000 devices, what causes me to want to look at that one?
Now, sometimes you know which device you want to look at. Maybe you just installed a new device and you want to make sure that it's behaving properly and its fans aren't installed in the incorrect direction and the system's overheating. But other times you want to look at things at a more holistic basis, right? We're looking at Bangkok right now, and its CPU was looking a little hot at times. Is that a problem across all of your network? This is where you would want to use the metrics application. So I can go ahead and check out CPU usage across all of my devices. And I'll go ahead and pull up the CPU utilization for every single switch being managed by CloudVision.
Well, Pete's example was 1,000 of them.
Yeah, so clearly there's
an improvement to be made to that graph.
Yeah, so I think this is one of the things I have a lot of fun doing is figuring out, OK, how do you scale this at different sizes? At about 10 to 100, being able to just scroll quickly through a list is really powerful. You can quickly understand trends, and eyes are really good at spotting that sort of thing. At 1,000, you're going to have a much harder time. You're going to want to rely on the events application. One of the things that I'm really excited that we're working on is partition searches. So I can search for, maybe I want to look at all of my systems that are running this EOS version, or all of my switches that are of this model. And you can start to do tag token searches as opposed to looking at everything in bulk. You can focus on dynamic partitions and be able to look at aspects of your network cut up.
So that's a good partial answer, and I appreciate the visibility here. The reason I asked the question is that I see net management tools as being stuck on providing visibility, and it's kind of no, we need intelligence, we need actionable information.
Yeah.
Yes. Yeah.
Okay. Can I be brutal?
Yeah.
How is this better than HP OpenView?
Better than. Sorry, what?
How is this better than HP OpenView?
Wait a minute, you set the bar too low.
Okay.
I mean, I think we could drill into the different platforms. What I really like about what we're building is we have a ton of experts at Arista on Arista gear. So I've been showing some more trivial examples here. CPU utilization. Everybody and their mother shows CPU utilization.
Yeah.
We have a lot of other metrics that we can analyze and understand and then provide actionable information on. Yeah.
OK, so you have CPU utilization, you have all the ones that you just referenced, okay? Let's say that we have Pete's example of 1,000 boxes. What's important out of 1,000 boxes times 1,000 data points per box? That's what Pete's question was, is how do we know where to go look? Because you have the data, that's cool.
Yeah.
But we don't know where to go look to find it. And scanning 1,000 by 1,000 is not going to happen but more than like once a year.
Definitely.
Probably right after we turn it up and go, this is pretty neat, but I don't know how to use this tomorrow.
Yeah. I completely agree. And I think this is where the event-driven piece of this comes in. On the back end, we have these turbines which are looking at all this data for you in real time. So as state is flowing through the system, it's looking at what's the state and analyzing if anything's wrong. And if so, it'll create an event for you to look at. And if you're talking about wide-scale visualizations, if you really want to say, no, I do want to look at all 1,000 things simultaneously, there's some really cool visualizations that you can do.
No thanks.
No, but what really is the question is, okay, so you have events, but what Pete and myself and Terry would love to have from you is some intelligence that would, based on your knowledge, because this is EOS, would say, okay, because I'm seeing this and this and this and this correlated to this, we think you might have this problem.
I think
when are we getting there?
Yeah, I think so. The example I always like to think about here is interface up-down events. Those everyone can monitor up-down events, but they're really noisy. Interfaces go up and down all the time in a data center. With CloudVision, you can calculate the topology, and I know how all of my switches are connected to one another. And then what I can do is say, look, I know both of these switches. I'm getting state from both of them. If either of them were administratively shut down or rebooted, I mean, I expect the interface to go down. I shouldn't generate an event for that. But if neither side knew that the interface was about to go down, that's when I need to generate an event and tell people about it. So these are the turbines that we're building out on the back end. Some of them are doing anomaly detection. This deviation by standard deviation will generate an event. Some of them are actually doing more complex topology calculations and analyzing things together that way. And then they'll produce.
But these are things coming down the line. You're working on them now.
We have varying degrees of intelligence here. So we do have some connectivity. They haven't factored quite yet into events. We actually just shipped the first general availability release of this, and we have releases coming out very frequently beyond that. So it's a very, very much an active product.
You said we can monitor a routing table, MAC address table also on the devices, right?
Yeah, you can go ahead and look at the routing table and see all the routes at any given.
Would that be possible to create a model of the network, how we want the network to behave, how the network status must be, should be?
The intent.
The state. Intentional state. Like we saw this morning, I create a model, I want my network to behave like this, and check if it is behaving like that. And if I receive something from the stream that goes outside my model, I want to have a high-level alarm or something to check. Like I don't see this MAC address anymore on the table of that switch, and it is the MAC address of an important server, so I want to get notified.
Yeah. So I think that I think that's a great example of something to track. And the general question of, all right, I want to make configuration changes confidently and understand when things go wrong is definitely core of what we're building here. The next part of the demo, I was going to show a configuration change actually taking place and how monitoring fits in there, which I think hopefully addresses.
No, not really, because I want to create a model of how the network behaves before. So I can check if the configuration change breaks anything that it is very important at the moment. Because I just need to have, I want to define a prefix on a routing table, a MAC address or something else, and just to check if I receive any stream from the device that changes the model, that goes outside the intent of my model.
So if you're using CloudVision, I don't know if you're familiar with the CloudVision provisioning side of things, which is really all about the configuration management, where you can define high-level configuration snippets and then apply it across your network. So you're not going on a device-by-device basis and saying, I'd like to do this here and that there.
Yeah, I think maybe one way to look at it is you have the config provisioning, and we showed earlier the telemetry. Like, are there any ways to tie them together to say, config could be compliant, but maybe a new configuration impacted something on the operational side of things, or generated an event based on a new configuration. So it's more or less, I guess, looking at it, closed loop system, and being smarter about what's deployed within the network.
So let's apply a configuration change.
Or if I can, before we go there,
All right.
reduce this to hello world of intent. Can we take the snapshot of a routing table and BGP neighbors and OSPF neighbors and LLDP neighbors before the software upgrade and after the software upgrade and compare whether they are the same?
Yeah.
Okay.
Can
We
you,
have something.
can you apply your future state to your operational state before actually configuring anything and have some understanding or how your future state is going to change your network?
This is so you can, as you change configuration, what we show you is how this will actually, so as you update your rules in CloudVision, what we'll do is we'll show, okay, how is this actually going to affect your running configuration?
Before pushing configuration down.
Before pushing the configuration. So if we go ahead here and I'm going to actually add a configlet, this is a small cluster of switches. Right now, there's a really permissive route map. We accept any of these AS paths. Now, for these couple switches, I actually want to lock that down in a little bit more detail. So lock this route map down. So we can actually, I pre-created a configlet for the ease of demo, but essentially I'm going to only permit these AS paths. That's what I'd like to do. That's my intent. And so I'm gonna unapply the route map permissive and apply this particular Vantage route map so I can keep this part of my network locked down. And then I will go ahead and update these two switches.
Before you update, so if you apply your new policy to your login, you should be able to see your next
update
plugin
might be a
before.
little bit of a misleading term. About to saving is where I'll actually apply it. So until this point, this is all I'm updating the staged configuration, but nothing's happened yet. So I can actually go ahead and preview what will happen.
Could I see my future routing table with new route map applied?
We don't try and emulate the future routing table at this point in time. So if I go ahead and save, there's actually a couple steps here because a lot of network operators like to partition these things into two steps. First, apply a configuration change, propose a configuration change, have it reviewed just like you'd review any sort of code, and then be able to apply it. So this created two tasks that I can go ahead and look at. I can look at the proposed configuration. So we'll go and look at what's the actual running configuration on the box right now, and then we will put together all of the configlets, and these are arranged in hierarchies, so you can create hierarchies of configuration, and you can see what will actually change on the box. So you can see there's a line change. The current running configuration is .any, and it's going to go to my new path. So if we're all in favor of this change, I can take these two tasks, and I can go ahead and tell CloudVision to push it out. So now it's going. You can see on the right-hand side, the configlet pushes in progress, and it's going to go check the configuration, make sure it's valid. If it was invalid, it would abort and give you an error, and it's now completed. So it went ahead and pushed that to multiple devices.
So do I have to push config to get inconsistency error, or would it be checked before it's actually pushed down?
So if you made a configuration change but you didn't actually push it, you would get a compliance error at a point in time saying, hey, look, the proposed configuration is different than the active running configuration. Do you want to reconcile the config and make what's on the box the official one, or do you want to actually overwrite what's on the box and make it yours? So let's go over to the telemetry application. And we actually just gotten an event. This event wasn't here earlier. We have higher than normal latency to DC US1. So we can go ahead and click on this and try and actually look at what's going on. It looks like when I made this routing table change, this is at 5:16 a minute ago, we have this latency measurement, which was a little bit noisy, but it was kind of in the, let's pop this open. It was be from 0.2 milliseconds, kind of jump up to 7 milliseconds now and then. But now it's steadily at 9 milliseconds. So something went wrong, and our software noticed that there was a big jump from what used to be the latency to what the current latency is.
How do you define normal there? It says higher than normal.
Yeah, so you can look over a longer period of time and try and understand, okay, is the latency that I'm seeing now anomalous? And you can.
So you are doing some baselining and anomaly detection.
Yes.
Nice.
Maybe I misunderstood your question, and the answer then was yes. So what we're actually looking at here is one of our new features for connectivity management. So you can have your switches monitor some remote destination endpoint and try and understand how that latency has evolved over time, packet loss, jitter, and any of these metrics which are important for dealing with a hybrid cloud sort of situation. So you can see you have some higher latency to AWS, but if you open up AWS's, it's pretty much always at 146 milliseconds. Nothing's changed there. The event that we got was for this one to DC US West 1, where previously we were seeing this slightly jittery latency, but now it's pegged at a much higher latency. So this, I think, was going a little bit to the question you were asking. I didn't want to have to go to this page and manually look at it and say, oh, this is the darker green than normal. I want to be told when something's wrong. And that's what the turbine applications in the backend are doing. And all this is happening in real time. If I go ahead and look at this live, you can watch this number. It's 9.8 milliseconds. It's 9.9 now. So this is changing as I'm speaking, and you'll be able to follow along with this graph. At the bottom, we offer some historical information to say, OK, here's how things looked previously.
But you define these pairs of measurement points yourself. I want to measure latency between here and there.
Yes, for this feature, we want to say, yeah, I'd like to monitor this cloud or this endpoint.
So it's like IP SLA. OK.
And so
you apply that change to BGP, to a route map, right?
Yeah.
Can we see what happened to BGP if now we have more prefixes, less prefixes, or something?
Yeah, so I can look at where this applied, and this was on the v4 routing table. On the right-hand side, I show recent routing table changes. You can see at 17.16 there were some changes. Okay. And actually, this was removed. 172.16.01 was removed. So I can look over here, and actually, let me just type this in 172.16.0.1. You can see, so here's my eBGP routes at about the time of the event. I can look at how things looked originally, and you can see that there used to be two uplinks, this used to be ECMP'd across two different interfaces. My route map borked things a little bit, and if we look now, it's only ECMP'd up over across one uplink.
Do you show a summary at all, like the number of prefixes or routes before and after at a given point in time?
Go ahead and look at the routing table count. There was 35 routes. So that's actually a good point. So the number of routes in this case didn't change. We should actually add a number of next hops. That would be a useful metric. We don't have that showing here, but that data is in the backend. And just finally, to close the loop, when you notice something's wrong, you often just want to say, OK, I want to undo what I did before. And this is where rollback comes in handy. We know what the network looked at previous points in time. You referenced snapshots. We can go ahead and say, look, I want to roll back to a previous well-known version of the network. I don't care about what it is now. And so we have systems to go and check the configurations, current and previous. And then we can go ahead and specify a previous point in time. Maybe I'll do it at 5 o'clock, 5 p.m. Sorry, 5 p.m. down here. And the system will make sure that everything is valid. And once it ascertains so, I can create a change control list and execute it. And let's open up a telemetry demo. On the side here, you can see the connectivity. We'll actually trying to show this on the screen at the same time. But you can go ahead and look at this in live mode, and you'll be able to see that this dropped from 10 milliseconds, and it's back down to it's fallen back down to its normal, its original latency state.
Is it possible to add one step for approval for the change? Like I propose a change and appear or somebody can approve the change?
So I skipped it in this one, but at the beginning when I did the configuration, it went to a tasks page, and then somebody else. If I'm a CVP admin, so I can do everything to my heart's content, but we could change permissions so only somebody else could approve the task.
Okay, great.
Will this platform allow me to push a change, and then if the box goes offline as a result of the change, reverse that change to bring the box back? That's a question from Twitter.
Yeah, so if you can't connect to the box, CloudVision might have a little bit of a hard time connecting to the box.
I guess we'd be presuming an out-of-band network here.
Yeah, so as long as we can access the management interface, then yes, you'll be able to roll back the configuration.
But would it do it automatically is the question.
Oh, no, right now we don't have any of these automatic triggers. On an event like the box going unconnected, then automatically triggering a rollback.
Right.
We don't want to do that quite yet, but that's certainly something that you could build with APIs that we expose.
And what he's really asking for is reloading 5.
Yeah.
Config commit in.
Yeah.
So this potential rollback could be pretty handy. I've seen a number of change windows where the rollback planning was substandard.
Yeah. I mean,
like missing?
One of the things we really want to do is just say, look, you shouldn't have to worry about like doing all these pre-steps and post-steps. Let's collect all the data. Let's make sure like we're keeping track of everything as it goes on. And if something happens, you should have enough state to be able to say, jump back to an original point in time and be able to look at a previous point in time without scratching your head.